Sup. Now think about this case, that you have built a very good backend system, a single web server for now, right? This is a single web server. Now this single web server handles a lot of requests, and those requests are very intensive in nature. For example, if I, as the client over here, send in a request, then that will take probably an hour or so for the web server to process and then return a response. So now over here, what do you think will happen if an other client, a client 2, tries to send a request to the same web server? Now in the case the web server is a single threaded web server, that is, it can only run a single thread, then the server won't respond to this client at all. It cannot, because it is already processing something else at the moment. The user experience would be so bad over there, right? So how can we avoid all of this? How can we make sure that when we have a request that is very intensive in nature or unpredictable in nature, or maybe very resource hungry, either of them, then how do we handle such requests at scale? Because for example, if you're just building your application for yourself, which I hope that's not the case, if you're not building an application just for yourself, then you would probably need a very scalable system. You'll probably need to handle millions of users. So how can you do that? So an approach to this is to use something known as message queues. Now, when we're talking about message queues, before that we need to understand what a web server is. Now this web server, if any task that is coming to it is very resource intensive, it should not be processing it. I don't care who you're building this app for. It should not be processing it. They should probably, the only role for the web server is to take the request that it has received from the client and send a response back as soon as possible. It should not be doing anything intensive. It should not be doing anything that is very time consuming or very resource intensive or stuff like that. It shouldn't be doing that. Its role is to take in a request and then send the response back as soon as possible, right? Perfect. That makes sense now. So even if I get another request from the client, because of the nature of my request, because they are so small, I can quickly respond back to this client from a single server. So what we'll be doing is that whenever we receive this intensive request that I was talking about from the user, I'll be accepting it and I'll be storing that somewhere, right? And similarly, whenever I receive another request from another client, I'll be again storing that request somewhere. Makes sense. We're storing the requests that we're receiving from multiple clients that are very intensive or probably unpredictable in nature. The time to return to the client is unpredictable in nature. We'll be storing them somewhere. Now, where do you think we'll be storing them? What do you think should be a right approach or a right data structure that we can use to store them? We want a data structure wherein we are enqueuing data, that is, we are adding in data, and then one at a time in the order in which they came in, that is first in, first out. In that order, we want to again receive data on some other server that we have created, right? Now, what will that be? What do you think this data structure over here will be? Well, it will be a queue, because this is exactly what a queue is, right? It's a FIFO, a first in, first out data structure. And that's exactly what we need over here. So I'll be storing in my requests inside my queue. And for now, I'll have a single consumer over here on this side. This will be a consumer of data. And this consumer will pop or dequeue data one at a time from this queue and process it and then send it back to the user. Now, how will it send it back to the client? You can probably send another request to the web server stating that, hey, I'm done with my work. And then this web server can handle how it will be sending data back to the user, right? Or we can enable some notification systems, which again will be using some different sort of mechanisms. We'll not be talking about notifications in this video, not at all. We'll be just focusing on this exact architecture that we're talking about right here. That is this web server sending data or pushing data onto a queue. And then one at a time, our consumer, that is an other server, will be pulling data or popping data out of this queue and processing it, however long it takes, processing it, and then sending it back to the web server. And then web server will be sending it back to the client. what this web server is doing is that it's essentially producing data, right? It's producing data, or messages as they are called. It's producing messages. And this web server can also be known as a producer of data. So this way we can have multiple consumers, not just one. For example, if our system is getting too overloaded and our queue is getting very long, so in that case, we can scale our system in such a way that we have multiple consumers over here. And all of them, one by one, take in data over here, different data. Like, for example, this consumer will be probably taking this data, and then this consumer will be taking the second data, and the third consumer will be taking the third data, and so on. And once they're done, they'll again be looking for the next item inside the queue. And this is very, very scalable. Your clients can send in requests to your web server, receive response as soon as they send it, almost instantaneously. And the web server will be pushing data onto your message queue. And then your consumers will be pulling from that message queue. That's how simple it is. What we have covered over here is basically known as async communication between servers, because what is happening over here is that our web server is indirectly communicating with our consumer, right? Asynchronously communicating with the consumer, because it is sending data to the message queue, and the message queue and then the consumer is pulling data from the message queue. So in a way, they are asynchronously communicating indirectly. So anytime you're thinking of implementing an architecture or backend systems where you want two different web servers to communicate asynchronously, you should probably thinking along the lines of a pub sub or a message queue. Now, how is a pub sub different from a message queue? Now, if you don't know about PubSub, I've already made a video discussing about PubSub in detail, so you can go ahead and check that out. But essentially, the difference between a PubSub and a message queue is that in a PubSub, we want all the consumers of that PubSub or that topic to receive a single copy, at least a single copy of the data or the message that we have sent. But in the case of a message queue, we don't want all the consumers to receive the same exact message, right? We don't want that to happen. That'll be pointless in this case. We want each consumer to take a single data and then process it and then send it back to the user. Now, how it will be sending back to the user is not really the point of this video, so we won't be getting into that. This system is really scalable and it allows you to decouple different servers that you have. That is, it allows you to build a web server that is only responsible for making instantaneous, that is very, very fast request and response from the client to the server and back to the client. And this consumer is responsible only and only for processing the data that it receives. And that's it. So this is what a microservices architecture is also known as. In this case, what will happen is that you can specialize each server. For example, you can have this server written in such a way that it is very efficient as a web server. You can have this consumer written in a language such that it is very, very efficient in consuming the data. And that's about it for message queues. Now let's see how we can actually implement this inside Node.js. Alright, so let's start by installing Express into our server. And we should also install the types of Express into our application. Alright, so this is how a basic Express server would be looking like for now. Let's go and start the development script in pm run dev. And let's open up Postman to see if we are receiving any request. And we do receive hello world, which means our web server is up and running. Now let's go ahead and install Redis. That's right, we'll be using Redis as the message queue broker for our application, for our server. So let's go ahead and install it. npm install Redis. This is one of the famous clients directly from the people who have actually made Redis. Alright, so first up, for running Redis, we'll have to start our Docker engine. Now once the Docker engine is running, what I'll do is I'll simply run the Docker image for Redis and I'll name it Redis Q. And I know that's not the spelling of Q, so don't worry. And now if I have a look at my Docker desktop app, I can see that my Redis instance is running now, which is great. And now that our Redis system is running, we can go ahead and run the client inside our Express server now. So we'll be creating the client and be storing it inside the client constant. If there's an error inside the client, then we'll be just simply logging it out. And then when we are starting our server, what we'll be doing is we'll be awaiting for the client. And let's see what this does now. So it's okay. So I'm getting an error over here that I cannot connect on the port 6379. Why is that? So I think the error is has something to do with the fact that I did not expose my Docker port. So I'll go ahead and do that. First, let me kill this instance which is running. Docker kill. Now I'll be running this on port 6379. So we'll be doing docker run, the same command, but except we'll be passing in a flag -p, which will be for the port. So this is the command for that. Good. And this is how we expose ports inside Docker. And now what will happen if I try to connect? Now I should probably not get an error. Yes, connected to Redis and server is running on port 8080. So there are essentially three methods that we should know inside a queue in Redis. The first is the L push, which basically means that we are pushing data onto the queue. Then the second is R pop, that is we are taking data out of the queue, that is we are dequeuing it. So the third method is BR pop, that is a blocking pop. What BR pop does is that, think about the case where your queue has become empty. Well, in that case, the consumer will have to constantly poll the queue for new data that it will receive. But we don't want that. So what we can do is we can instead wait on the queue for it to receive data. This is exactly what BR pop does. It's a blocking operation that we can perform and wait for in this case, an infinite time for the queue to send us data if the queue is empty. Now this can obviously be manipulated. This can be changed to 30 seconds, 40 seconds, or whatever timeout that you specify. So now we'll be seeing how we can use the L push method. That is, how can we add messages onto our queue. So for that, I've created a post route inside my Node.js Express server. And over here, I'll be listening in and I'll be receiving a JSON body, which will contain an operation. Now the JSON body, as you know, can be manipulated and changed into whatever you want to be. And this operation can be anything that you want. But I just want this example to be very simplistic, and that's why I'm using this. So once we receive request on our intents operation, what we want is that we want to push the data, that is the operation, onto our client. Now what is operations? Operations is the name of the queue, and L push is the method that we'll be using to push data onto the queue. And as you know, data in Redis can only be stored using a string, and that's it. That's why we'll have to first of all stringify our method. That is why we have to stringify our value. So that's what we are doing over here. And once we have stored it, we can simply send in a response that, yeah, we have received it, everything's fine, great. And here we will be handling any Redis error that we get that probably we couldn't add, a Redis client is probably off or something like that. We'll be handling it over here and sending in a 500 that, okay, that's our fault. It's a internal server error. We failed to store your data. And now, as you can see, there is no validation over here, nothing of that sort. Very simplistic for now. So let's see how we'll be using this using Postman. Let's change this into a post route and intents operation and body. And I want this to be a raw JSON. And over here, I'll be sending in operation as first. All right. Fingers crossed. Let's go. Okay, received and stored. That's great. But how do I know that my Redis has actually stored this data? So for that, I'll be using Redis Insight, which is a GUI for my Redis instance. All right. And I have a list over here, which is the operations list, and it contains an operation first. Amazing. Amazing. And now let's add in something else like second. Great. This should also be received, and let's check it on our Redis client, Redis Insight. And yes, we have received the second. First is what will be processed before second. How can I prove that? Well, let's finally work on the consumer. That is the worker of our queue. That is the method that will be used to consume from the queue. So let's check that out. Alright, so this is what our consumer will be looking like. We'll have a start consumer function first of all, which will be the entry point for a consumer. And now please keep in mind that your consumer is probably going to be a new separate server. It is not going to be the same server that is also handling intense operation. That is the one that is pushing data. Most likely, that's not going to be the case, where it's going to be the same server that is pushing data onto the queue, and then the same server which is receiving or pulling data from the queue. It's not going to be the case. So consider that consumer is a different new server, right? And now over here we have a similarly as we had in our server a start function, we're going to have a start consumer entry point. Now similarly we'll be connected to the same client, the same Redis client, which will probably be hosted somewhere. And once we're connected into it, what we'll be doing is that we'll be running in an infinite loop. Great. But what are we doing exactly in that infinite loop? Inside the infinite while loop, we're taking in the operation that we're receiving from where? We're receiving it from the client and using a break pop method. We'll be popping off the first element that it received, the first element that it received inside the queue, and popping it off the queue. And then we'll be processing it inside this process op method. And what this process op will do is, for now, it's just logging in the processes that it's performing. And I've inserted a fake delay over here of 2 seconds so that I can actually process it. And yeah, it's parsing data from the intense operation that it received from this over here, which is exactly what we want. We are receiving the element over here. We are not worried about the key right now. We only want the element right now. That is our data that we have pushed. That is the operation data that we had pushed over here. The operation data that we had pushed over here. And we'll be processing it, sort of fake processing it, and then just logging it out. So let's see how it looks like. But before that, we need to actually call this somewhere. And I'll simply be calling it over here. I'll be importing it. All right. Now let's see our server. All right. So why is it not processing anything? Okay. So I think the reason for this is that over here, we are adding the client, that is, we are adding the data to the operations queue. But over here, we are taking data from a different queue. So that is the problem. Once we fix this, we should see processing first and then processing second. And now it's waiting for us. So if I add anything very fast, let's go for third, or I'll just be adding numbers for now. Third, fourth, and fifth. Now if I see my terminal, I can see that it processed third, fourth, and fifth, and it's still waiting for more data to come into my queue. That is exactly why we have used brpop instead of a regular rpop. That is pop data from the queue. And if you notice the order in which it will process the data, it first processed the data first. That is the data that it received at the absolute beginning. And then it moved on to the second one, the third one, the fourth one, and the fifth one. And this is exactly how we can make Redis queues work inside a Node.js server. Now again, this consumer will probably be a different server. Yeah, that's about it. I hope now you got a practical understanding of how queues, that is message queues, work in the real world, what they are used for, and how to implement them inside a Node.js server. Yeah, this was so much fun. I'll see you in the next one.